Good afternoon. Welcome to the and Herman 7th grade science show. Special edition for obvious reasons. Dave's not here. We'll try to do the best without him. Let's begin. All right, students. So in this lab number 10 is about magnetic and electromagnetic reactions as it relates to chemical reactions. So you should have two of these magnets in your kit. They are ceramic, and so they will break, so be a little careful with them. Find a paper clip, and that's what you're going to need for particularly the second part of the lab. The first part, you should download and print this form, or one much like it's easier to, and I want you to simply do some playing around with the magnet. Find things that you have around the house, like a plastic spoon or a pen, and write here what the object is. If you think it's going to be magnetic or not, write it in first before you test it, and once you've written it, then test it. But don't test it until you've made that prediction you think it's going to be magnet or not. So let's give an example. I have a rock. I'm going to see if the rock is magnetic or not. So if I take my two magnets, and I'm going to write on here a rock. I don't think it's going to be magnetic. I was right. Not. And the correct was correct. So I found a part. I predicted what it would be, and I marked it. I was correct. Take another one. Plastic blocks. I have little plastic blocks. So I'm going to write down here plastic blocks. I'm quite sure they are not magnetic. And I'll try the magnets on it. Right. Then I have, what else? I have a bell. I'm going to predict that the bell is magnetic. Yes, magnetic. I'm going to test it. What else my bag is? I use this one. Oh, here it is. Very magnetic. So yes, I was correct. I'm pretty good at this. Try different things. You may have some magnet for refrigerator magnet. The front's going to be not magnetic, but the back has a magnet on it, and that will be magnetic. All right, so test a couple of them. Come up with 5 or 6 things. You might have a toy. This is a toy I found here in the classroom. I'm not too sure, but I think it's meant to look like atoms and things like that. It's kind of cool. But again, it's just a toy. I want to demonstrate something that I don't really understand. Here's some fancy magnets, north and south. Obviously, if we put the north to north, they're going to repel each other, right? If we put one piece of metal between them, they no longer repel each other because they become one with that. If I put 2 pieces of metal between them, they go back to repelling each other. Magnets are fascinating things. And that's the end of the first part of the lab. So fill in this sheet or the one much like it. And if you have, well, we had the steel wool from before, kind of an interesting thing. If you have some steel wool from the last lab, you can cut it up and make it into a pet. I have a pet here, and the pet is trying to get away from me. It's a vicious pet. It's trying to attack me. So you can take steel wool and cut it into pieces. But with a warning, if you get the steel wool on this magnet, you may never get it off. Anyway, one more thing to play with. Find some things around your house that are a magnet. Think maybe a magnet. and test them out. So welcome back. This is part 2 of the lab number 10, and I have gone to the trouble of painting Na on one. That's going to be our example of sodium, Na, and Cl on the other, our example of chlorine. They're really good examples because they bond everywhere so quickly. What I want you to realize today, as you fill out page 162 and 163 of the McGraw-Hill textbook, I need you to get a sense that the magnet fields are very similar to the electron bonds in different compounds. So what I want you to what I want to show you is if I have the paperclip, and this is going to be the part of the electron, and it's stuck. It's an extra electron that sodium. Sodium's got one electron in its outermost valence, and it kind of gives it away, called an explosion. And if I have chlorine comes along, it can't pull it off too easily. It can, but not too easily. But because sodium is more complicated, there are layers of valence levels, or layers between the nucleus and the electron. This distance is going to be demonstrated if it's a very simple atom. The distance is going to be really minimal, and little old chlorine can come over here and just yank that electron away. So if the electron is stuck to sodium, chlorine can come over and take the electron away. That happens every day and it's called salt. But notice if the atoms become more complicated, and I'm going to show that by putting a couple layers of paper in here. And try this. Use some cards. You have 2 cards in your lab kit. Put the cardstock between the proton and neutron and nucleus. And now it's even easier for this other guy to come in and use magnetic force to take away the paperclip. So the more complicated the atom, the more layers in the valence they have with all the layers of the electrons, the easier it is for it to make a reaction. And that's why if you have your periodic table, you'll see on this side, these people over here all kind of act the same. It's a family, familia, a group, a column. And they all wear the same clothes. They all act the same way. They all do the same thing. They all, on this side, they all explode. Hydrogen explodes, lithium explodes, but because these have more layers of electrons, they explode more. They're dangerous. Because they have more layers, then anybody coming along can take the electron away quickly. That is part 2. Finish the book on page 162 and 163. And that will be, and then show me a picture of it. And that is lab number 10. And that's the bell says class is over. Thank you. And we miss Dave because he helps do this a lot better quality. Goodbye.